This is part 3 in a series on solving trig equations. If you did not see me solve problems 1 through 8, you should probably go back and watch those videos first. So there's a couple sets of facts that you need to have memorized. This is one of them. You need to know all of these trig facts. So if you haven't memorized this chart yet, copy it down and memorize it. Same goes for this table of trig identities. You should be able to reproduce this chart within 1 minute. Alright, I'm going to assume that you can do that. Please don't let me down. Now, on this problem, I see that we have sine squared, and that's the only thing we have in terms of trig functions. So I'm going to go ahead and add 3 sine theta to both sides, 3 sine squared I mean. Put those like terms together. Alright, so that's actually going to give me 4 sine squared theta is equal to 3. Now, it will be easy for me to get this sine squared theta by itself by dividing both sides by 4. So that's going to give me sine squared theta is equal to 3 over 4. To unsquare sine squared, I need to take the square root of both sides. When you take the square root of both sides, the solution can be plus or minus. So don't forget that. It's a common mistake is forgetting the plus or minus. So this will give me sine squared, well, it's not squared anymore. This will give me sine theta is equal to plus or minus. Now I'm going to go ahead and put radical 3 over 2. Remember that when you take the square root of a fraction, it's really the square root of the numerator and the square root of the denominator separately. Radical 3 just stays radical 3, but the square root of 4 is 2. Now let's talk about what the reference angle is. Okay, ignore the plus or minus for a second. The sine of what angle is radical 3 over 2? Hopefully you were thinking pi over 3. The sine of pi over 3 is radical 3 over 2. That tells us that the reference angle is pi over 3. So here's a diagram of multiples of pi over 3. Alright, so these 4 angles right here are the angles that have a reference angle of pi over 3. The sine function is positive in, well, sine is a y value on the unit circle. So that's why sine is positive in these 2 quadrants and negative in these 2 quadrants. However, because we have plus or minus, we want all 4 of these. All 4 of these will be solutions. So that's why the answer is going to be theta equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Alright, so that is the answer to number 9. Well, number 10 is a new kind of problem. We have 2 different types of trig function, and neither one is squared. And that's the problem, because normally I would fix this by using something off my trig identity chart. I do a substitution. But nothing is squared, and everything on this chart is squared. So to fix that, what I'm actually going to do is square both sides of the equation to get some squared things in here that I might be able to substitute. However, before I square, let's separate these to so we won't have a big ugly combination of cotangent and cosecant. So let's move cosecant over to the other side, so we're just only squaring cotangent and we're squaring cosecant separately. So that's going to give me cotangent theta is equal to cosecant theta plus 1. All right, and then now I'm going to square both sides. So that's going to give me, maybe I'll just change colors to show that I'm now squaring both sides. All right, so that's going to give me cotangent squared theta is equal to, when you square a binomial, you are really just multiplying it times itself. Okay, so nothing to do over here on the left side, but over here I am going to double distribute. So cosecant times cosecant is cosecant squared. Then cosecant times 1 is cosecant. And then 1 times cosecant is another cosecant. And then 1 times 1 is 1. So that's going to give me cotangent squared is equal to cosecant squared plus 2 cosecant plus 1. Okay, now I have cotangent squared. That's going to be on the chart. So let's see. Cotangent squared is equal to cosecant squared minus 1. So here we go. Cosecant squared minus 1 is equal to cosecant squared theta plus 2 cosecant theta plus 1. All right, let's subtract cosecant squared from both sides. Interesting. And while we're at it, let's add 1 to both sides. All right, so I'm getting 0 on one side. So these cancel each other out. So that's going to leave me with 2 cosecant theta plus 2. So subtracting 2 from both sides, I will have negative 2 is equal to 2 cosecant theta. All right, dividing both sides by 2, I'm going to get negative 1 is equal to cosecant theta. All right, and this, of course, would be the same thing as having cosecant theta, cosecant theta equals negative 1. Now, cosecant is the reciprocal of sine. So taking the reciprocal of both sides, we will have sine theta is equal to negative 1. The reciprocal of negative 1 is still negative 1. And this is going to be a quadrantal angle situation. Remember that the coordinates on the unit circle, this is going to be 1, 0, and 0, 1, negative 1, 0, and 0, negative 1. On the unit circle, sine is a y value, so we are only to look at these numbers. And we want the sine of the angle to equal negative 1. So that means right here. So that means theta is equal to 3 pi over 2. Now this is probably the answer. I say probably because when we square both sides of the equation like this, sometimes we create extraneous solutions. Sometimes the solutions that we get don't actually work. So we should really take this and plug it back in to the original equation and make sure that it actually works. So let's do that right now. Alright, so we have 3 pi over 2. So let's see what happens if we plug 3 pi over 2 in here. So that would be, so this is our check. And we only have to do this because we squared both sides. Alright, so we have the cotangent of 3 pi over 2, okay, minus the cosecant of 3 pi over 2 is equal to 1. Now, remember that 3 pi over 2 is a quadrantal angle, so let's draw that one more time. 3 pi over 2 is right here at 0, comma, negative 1. So let's think about what x, y, and r are. So x is 0, y is negative 1, and r is 1. Alright, it's the unit circle. Okay, so what will the cotangent be? So remember that cotangent is x over y. Alright, it's the reciprocal of tangent. So cotangent is x over y. So that's going to be 0 over negative 1, which is 0. So this will be 0. Now, what about the cosecant? Cosecant is the reciprocal of sine. Okay, and sine is a y value. Well, yeah, on the unit circle. So sine is a y value. So there's negative 1. Now the reciprocal of negative 1 is still negative 1. So that's going to be negative 1. So the question is, does this equal 1? Well, of course it does, because the 0 is nothing, and then I have minus a negative, which is a positive. So it checks out. At first glance, number 11 looks really tricky, because we have cotangents, and then we have this tangent thrown in there, and nothing is squared, so I can't make a substitution off my identity chart. And I'm thinking, do I have to square both sides like I did in the last problem? That would be a mess because I got functions all over the place and radicals, and I don't know what's going on. But then I stop and I relax for a second, because right here, the only tangent is right here being multiplied times cotangent. So can't we simplify these in a really cool way? Cotangent is the same thing as cosine over sine. Okay, and then tangent is the same thing as sine over cosine. So cotangent times tangent is just going to be 1, because everything cancels out. So cotangent times tangent is really just 1. So that's just going to leave negative 3. And then the rest of it, negative 3 plus 3 cotangent theta is equal to radical 3 cotangent theta plus 3 cotangent theta. Okay, that's better. It's all cotangent. Great. I'm noticing that I have 3 cotangent theta on both sides. So if I were to subtract 3 cotangent theta from both sides, those would cancel out completely, wouldn't they? So that's going to leave me with negative 3 is equal to radical 3 cotangent theta. Well, this problem is getting more simple by the minute. So to get cotangent theta by itself, I will divide both sides by radical 3. So that will leave me with negative 3 over radical 3 is equal to cotangent theta. So this looks weird with the radical in the bottom. So I think it will be in our best interest to rationalize the denominator. So let's multiply the numerator and the denominator by radical 3. So that's going to leave us with negative 3 radical 3 over 3. All right, radical 3 times radical 3 is radical 9. Radical 9 is 3. But then these 3's cancel each other out. So that's going to leave me with negative radical 3 is equal to cotangent theta. Okay, this is great. Now, cotangent is the reciprocal of tangent. So taking the reciprocal of both sides, all right, the reciprocal of cotangent is tangent, and the reciprocal of negative radical 3 is negative 1 over radical 3. Okay, so now let's talk reference angles. Tangent of what angle is 1 over radical 3? Or which is the same thing as radical 3 over 3. Okay, well that's pi over 6. Tangent of pi over 6 is 1 over radical 3. So the reference angle is pi over 6. Now, all right, here comes the diagram. All right, which you at this point you should be able to do this in your head without drawing this picture. But these are the 4 angles that have a reference angle of pi over 6. All right, because this is pi over 6 right here, and the rest of these are multiples of pi over 6. Let's see, tangent is positive in this quadrant and this quadrant, and tangent is negative in the second quadrant and the fourth quadrant. But in this particular case, we want tangent to be negative. So that's why we want these 2 answers, this one and this one. So what are those angles? So over here on the far left would be 6 pi over 6. So this is 5 pi over 6. Okay, all the way around at 2 pi would be 12 pi over 6, so this is 11 pi over 6. That's not a very good pi. All right, and there you go. These are the answers. All right, let's do one more problem, and then that'll be the end of this video. And we'll just make one more video to finish out the series. So this one is going to be slightly different than the ones we've done before. All right, we're going to use a new technique. First of all, I just like having a 0 on the right-hand side, so I'm just going to do that. And here it is. There is a GCF here. So whenever you see that, you definitely want to take out the GCF. Oh, that reminds me of a common mistake that kids will make. Sometimes when students see that there is a GCF, they feel like they can just divide everything by the GCF. So some students will do like this and divide by cosine everywhere. This is highly illegal. You cannot divide everything by a trig function because trig functions are very often 0. And so you're indirectly dividing by 0, which breaks the universe. So do not divide by a trig function. Never divide by a trig function. Instead, if there's a GCF, factor it out. So if I take the cosine theta and put it out front, then that's going to leave me with radical 3 minus 2 cosine theta is equal to 0. Now I will set both of these 2 factors equal to 0. And so I will have cosine theta is equal to 0. And I will have radical 3 minus 2 cosine theta is equal to 0. So I think I'm going to solve this one over here on the right first. So subtracting radical 3 from both sides will give me negative 2 cosine theta is equal to negative radical 3. Dividing both sides by negative 2 will give me cosine theta is equal to positive radical 3 over 2. A negative divided by a negative is positive. Now, what is the reference angle over here? So the reference angle, cosine of what angle is radical 3 over 2? Hopefully you were thinking pi over 6. So the reference angle is pi over 6. Now, think about the diagram of multiples of pi over 6. All right, these four angles have a reference angle of pi over 6. Cosine is an x value on the unit circle, so cosine will be positive in the first and fourth quadrants, and it will be negative in the second and third quadrants because x's are positive on the right and negative on the left. In this particular case, we want cosine to be positive because we have positive radical 3 over 2. So that's why we want these two answers. So that will give us, all right, I'll put it more towards the middle. This will give us theta is equal to pi over 6. And this one down here is 11 pi over 6. All right, because if all went all the way, that would be 12 pi over 6. So this must be 11 pi over 6. Okay, now what about this cosine equaling 0? Well, that is a quadrantal angle, so let's draw the quadrantal situation. Okay, remember this is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. On the unit circle, cosine is an x value, so we should only look at these numbers. Now we want the cosine to be 0. So that will happen here or here. All right? Those two positions. So that's going to be pi over 2. All right? So I'm going to add pi over 2 to the list and 3 pi over 2. So this will be the answer to number 12. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.